Today we will study about interprocess communication. So what is interprocess communication? From the name itself you can understand that there are multiple processes which wants to communicate with each other, and that is nothing but interprocess communication. So generally in a system there are processes which can be independent or cooperating. So what is independent process? An independent process is the one that do not share data with other processes and cannot affect or be affected by the execution of another process. As the independent process is not sharing data, they will not get affected or also will not affect any other process. Now what is cooperating process? Process that share data with other processes are cooperating process. Such process can affect or be affected by other processes. And interprocess communication is all about cooperating processes. So we'll see more about this. Now the question is why process cooperation is required. So the first point is information sharing. So consider a system where there are multiple users and they want to share a file. So in this case the file is the information which must be shared by multiple users or multiple processes. So there must be cooperation among the users or the processes such that all of them can read the file and no one is left out. Second, computation speed. If we want a task to be computed faster, it must be divided into subtasks and each of the subtasks must be executed in parallel. So there must be communication between the processes to achieve this, that is to divide the task and assign the subtask to each of the processes, and that requires process cooperation. The third point is modularity. We have already studied in case of operating system structures where we have seen the modular approach where there is multiple functions or multiple modules are there which helps in communication between the process very easy. Fourth point is convenience. So suppose there is a user and he wants to do multiple tasks that can be editing, compiling or printing. So all the tasks are actually nothing but processes. So all the processes can work together by cooperating with each other. So that is why convenience is also one of the factor for process cooperation. Now cooperating process need interprocess communication, which is also called IPC, interprocess communication. And there are two types of models for interprocess communication. The first one is shared memory and the second one is message passing. So let us look at the first one, shared memory. So if we look at this particular diagram, we see that the kernel, process A and process B are all in the memory. Similarly, in the case of shared memory, kernel, process A and process B are also in memory. So in case of message passing system, process A and process B communicate with the help of send and receive system call, which is available with the kernel. So if process A wants to send a information or a message to process B, it has to take the help of the kernel to send the message with the help of send and receive system calls. So message passing system is little slower because of the intervention of the kernel. In case of shared memory, if process A and process B wants to communicate, they don't need the kernel. Initially they need the kernel just to share the memory, but after that process A and process B can communicate with each other with the help of this shared part. That is, suppose there is a file which is shared in this memory and process A wants to read the file, process B wants to read the file, both of them can read the file. Or process A may write to the file, process B can read the changes that is being done to the file by process A, and vice versa. So that is how message passing and shared memory model works. So let us see something more on shared memory. So in shared memory, the information is exchanged by reading and writing data in the shared data. So that is what we have already discussed. This shared data is being accessed by A and B both. So when A is writing something, B has to wait for it, or when B is writing something to the shared data, A has to wait. So some kind of synchronization is required between both of them. So initially this shared memory is established with the help of the kernel. So the kernel initially helps in setting up of the shared memory between the processes. So in this case, two processes A and B. So the kernel will help in setting up the shared memory with the help of system calls. Once shared memory is established, all communication is treated as routine memory access and assistance from kernel is not required. So once this is available, the shared memory is available, now process A and process B can do the communication like a normal memory access and kernel is not required. That is why shared memory is faster compared to message passing. The communication is under the control of the user processes and not the operating system. So this is also key point. Now the processes are controlling the communication and the kernel has nothing to do with it. Also synchronization is required between cooperating process, as if there is a shared file and process A and process B is writing to the file at the same time, one may overwrite the file content of the other. For example, process A is writing to the file, then process B is again writing to the file, process B will overwrite the content of the A. So content of A, the process A which was written to the file will be lost. So that is why some form of synchronization is required. You can understand it in this way also. Generally we have a routine while the taking class. So if there are two faculty taking class for the same batch, so the synchronization between the two faculties must. Both of them cannot go to the class at the same time. In this case, the class is the shared memory and process A is one of the teacher, process B is the second teacher. So the synchronization is done with the help of routine. Maybe first hour for the teacher A and second hour for teacher B, and so on. And we have already said shared memory is faster than message passing. Let us understand the concept of cooperating processes using one problem which is called producer consumer problem. So generally if we consider producer consumer problem, producer can be a server, consumer can be a client. The server can produce HTML files, images, text, and the consumer will consume the HTML files, the text, the images. So there must be synchronization or there must be cooperation between the producer and consumer. So generally we have buffers for storing the information. So server produces information and stores in the buffer and the consumer reads from the buffer. Now it depends upon size of the buffer. In case of unbounded buffer, there is practically no limit on the size of the buffer. So which is also actually practically not possible. In case of bounded buffer, there is a limit to the size of the buffer. Let us look at this particular example to understand more on that. So we have a buffer. As in this example, there are n slots. N is equal to 5. Now the producer is producing some data. Suppose this is the data produced D1, D2, D3, D4, D5. So producer is producing some data. Now consumer will be consuming the data from the buffer. Now there must be a speed match between the producer and the consumer. The speed at which the producer is producing, the speed at which the consumer is consuming must match. Otherwise what will happen? Producer will produce more and the consumer, if it is slow, it will not be able to consume, so the producer will override the data. Or if the consumer is too fast, then it has to wait, because the producer is not able to produce in the same speed as the consumer is consuming. So this buffer is generally a bounded buffer of some fixed size, and the producer is producing the items. When the buffer becomes full, producer goes to sleep mode, informing the consumer that the buffer is full. Now the consumer start reading or consuming the data from the buffer. It start consuming. When the buffer is empty, then consumer goes to sleep and it will send a message to the producer that the buffer is empty, you now put some data in the buffer. So that is how producer consumer problem works. So there must be cooperation between the producer and the consumer. So if we consider this is one process and this is the second process, so they must cooperate with each other, and we will see later on in case of producer consumer problem how synchronization can be done between these two with the help of a new concept which is called semaphore. For now we will stop here. In the next class we will see message passing system.